Hello, good morning. I am discussing about basic concept of chemistry. Usually, basic concept of chemistry is necessary in curriculum of class 11, science curriculum, and any vocational program like CTEVT, different kinds of disciplines. Uh, First of all, matter. Matter, it is anything which occupies space, possesses mass, and can be judged by one or more of the five senses. That is the vision. You can see, hearing, you can hear, smell, you can taste, and touch. Element, pure chemical substance which can neither be split into simple substances nor prepared by the simple method. For example, hydrogen, helium, oxygen, etc. are the element. Naturally, 92 elements in the nature. Compound, the substance formed when two or more chemical elements are chemically bonded together. For example, ammonia is formed by the combining the three hydrogen atoms and one nitrogen atom, formula NS3. Similarly, water has two water molecule and one oxygen molecule are bonded covalently and to form the ammonia and water molecules. Atoms. It is the smallest particle of an element which takes part in the chemical combination. For example, hydrogen, As, copper, Cu, gold, Au, etc. Molecule. It is the smallest particle of any compound. Example, S2, O2, N2. Molecules are various types. Okay. Molecules are various types, homoatomic molecules, molecules containing the atoms of same element. Homoatomic molecules are also divided into following. Monoatomic molecules, these are the molecules containing single atom of an element. For example, molecules of inert gases are monoatomic, helium, neon, argon, krypton, xenon, and radon. Diatomic molecules, these are the molecules containing two atoms of the same elements. For example, elementary gases are diatomic, O2, N2, oxygen molecule, nitrogen molecule, chlorine molecule, hydrogen gas, fluorine molecule. Polyatomic molecules, these are the molecules of same elements containing more than two atoms. Example, ozone, phosphorus, sulfur. Heteroatomic molecules, these are the molecules formed by the combination of two or more atoms of different elements. For example, hydrochloric acid, HCl, water, H2O, sulfuric acid, H2SO4, nitric acid, SNO3. Chemical symbols. Chemical symbols are the abbreviation or short representation for the full name of the elements, or an atomic symbol is one, two, or three letter notation used to represent an atom corresponding to a particular element. Had a list of chemical elements ordered by decreasing atomic order: hydrogen, helium, lithium, beryllium, boron. Significance of symbols. That is the two types of significance, qualitative and quantitative. Qualitatively, the elements is the aluminum. Quantitatively, one element of aluminum, one atomic weight of the aluminum, that is the 27 parts of weight of the aluminum, 1 gram atomic weight of the aluminum, that is the 27 gram of aluminum, 6.023 10 to the power 23 Avogadro's number. Molecular formula or chemical formula, it is a symbolic representation of molecule of a compound that shows the actual number of atoms present in the molecule. A molecular formula represents the exact number of each type of atom in a molecule. It gives the elemental composition of the molecules, but does not provide information about how the atoms are arranged or bonded. Example for glucose, the molecular formula is C6H12O6, indicating it contains the 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Some of the common chemical compounds in formula uh, oxygen O2, nitrogen N2, hydrogen H2, carbon dioxide CO2, carbon monoxide CO. Qualitative and quantitative significance of the molecular formula. Molecular formula have also the qualitative and quantitative significance. Qualitative significance represent the name of the chemical substance and its constituent. For example, water. Water is the H2O2, hydrogen and oxygen is the qualitative significance. And the quantitative significance represent the amount or quantity of the chemical constituent present in a specific chemical species. The number written before the formula also represent the number of mole. That, for example, 2s2 represent the 2 mole of water. That is the 2 into 6.023 10 to the power 23 water molecules. It represents the particular mass of substance. Example, atomic mass of the water is the 18 gram. That is 2s2 means 36 gram. It expresses the percentage composition constant. Example, percentage composition of hydrogen in water is the mass of hydrogen over mass of oxygen into 100, that is 11.11 percentage. Percentage composition of oxygen is the 100 minus 89, and then, sorry. Okay, the percentage composite of oxygen is 100 minus 11.1, 88.89 percentage. Radicals. A radical is an atom of an element or a group of atoms of different elements that behaves as a single unit with a positive or negative charge on it. Types of radicals, electropositive radicals or basic radicals. The radical having a positive charge on it is known as the electropositive radical or basic radical, and also known as cation, for example, Na plus. Electronegative radical or acid radical, the radical having a negative charge on it is known as electronegative radical or acid radical, and also anion Cl minus. Classification of radicals or simple radicals, those radicals in which a single atom of an element is called simple radicals, example Cl minus. Compound radical, those radicals in which a group of 2 or more than 2 atoms is called compound radical, for example sulfate is 4 minus minus. Complex radical, those radicals are made of by the contribution of the 2 or more different radicals are called complex radicals. For example, hexacyanoferrate represents of some radicals. These are the ammonium nitrate, nitrite, bisulfate, bisulfite, bicarbonate, hydroxide, acetate, sulfate, sulfite, carbonate, dichromate, phosphate. Valency is also whole in modern concept. In whole concept, it is the combining capacity of element is called valency. In the modern concept, valency is the combining capacity of element, usually measured by the number of hydrogen atoms it can combine with or displace it in a chemical reaction. In simpler terms, it indicates how many electrons an atom needs to gain, lose, or share to fill its outer shell and achieve a stable electron configuration, typically resembling the nearest noble gases. Or the valence is defined as the number of electrons lost, gained, or shared during the formation of the compound. Variable valency refers to the ability of certain elements to show more than one valency or oxidation state. Variable valency is due to the presence of multiple oxidation states and same energy level in 4s and 3d subcells available to the element depending on the nature of the chemical bond and environment in which the element is represented. Variable valency on some of the common elements. For example, in iron shows the common oxidation state +2 and ferrous chloride, ferrous sulfate, +3 in ferric chloride and ferric oxide. Similarly, steam also stannous chloride in stannous oxide, that is the +2 and +4 oxidation state. And also copper, that is the cuprous oxide and cupric oxide, copper sulfate. They have the +1 and +2, two types of uh, variable valency. Also, lead shows the two types of oxygen state, plumbous +2 lead oxide and +4 lead dioxide. Mercurius +1 oxidation state, mercurius chloride, mercuric chloride +2 oxidation state. Sulfur also have the four types of oxidation state. For example, hydrogen sulfide, sulfur dioxide, also found sulfur dioxide 4 oxidation state, and 6 found in sulfuric acid. Okay. In case of nitrogen, nitrogen exhibit a wide range of oxidation state. -3 found in ammonia and 0 found in the molecular nitrogen, and +1 to +5 found in various oxide of acids such as nitrous oxide +1, nitric oxide +2, nitrogen dioxide +4, and nitric acid +5. Valency of element, the valency is often determined by the number of electrons in the outermost shell valence electrons of an atom. For example, hydrogen has the valency 1 because it needs to gain or lose 1 electron to achieve the stability. Carbon has a valency 4 because it has 4 electrons in its outer shell and needs 4 more to fill it. Monovalent elements with valency 1, example hydrogen, sodium, divalent elements with the valency 2, oxygen and magnesium, trivalent elements with the valency 3, nitrogen, aluminum, tetravalent elements with the valency 4, carbon. Steps to writing the chemical formula, write the symbols of the elements which form a compound. Uh, First of all, we write the symbols of the atoms form to the molecule, and write the valency and crisscross to get the required formula. For example, S to S, it is the crisscross. Sodium chloride, sodium have valence 1, chloride valence 1, so that is the NaCl. And calcium chloride, calcium +2 valency, chlorine 1, so CaCl2. Aluminum oxide, aluminum have valency 3, oxygen 2, so crisscross Al2O3. Magnesium nitride, magnesium 2, nitrogen 3, magnesium nitride. Ferrous sulfate, ferrous valency 2, 3, and sulfate 2, this so ferrous sulfate. Sorry, ferric sulfate. Ammonium sulfate, valency 1 and phosphate 3, so crisscross ammonium phosphate. Magnesium chloride, magnesium valency 2, chlorine 1. Aluminum sulfide, aluminum valency 3, sulfur 2, Al2S3. Potassium oxide, potassium 1, oxygen 2. Calcium nitrate, calcium valency 2, nitro 1. Ferric chloride, barium phosphate, ammonium sulfate. A chemical equation. A chemical equation is the symbolic representation of the chemical reaction in the form of the symbol and chemical formulas. A chemical equation is the symbolic representation of a chemical reaction in which the reactant substance that start or reaction are written on the left side and the product substance that are formed as a result of the reaction are written on the right side. The two sides are separated by the arrow that indicates the direction of the reaction. Skeleton equation or equation which simply represents the reactants and products of reaction in symbols and formulas and which the atoms of different elements may or may not equal on both sides is called skeleton or skeleton equation. Zinc plus hydroxide is zinc chloride hydrogen. In this equation, the atoms of hydrogen and chlorine is not equal in both sides. uh, the reactants in the product in this reaction hydrogen and gas and oxygen gas product water the coefficient 2 and in front of hydrogen in water ensure that the equation is balanced, meaning the number of hydrogen and oxygen atoms in the same of the both sides of the equation. Essential of the chemical equation arrow notation, the reactants are written on left side and the products are written on the right side of the reaction. For example, H2 plus O2 H2O reactants in products. A balance equation, the chemical equation must be balanced. The balance equation provides the quantitative information of chemical equation. Chemical formulas, the reactants and products are represented by their chemical formulas, S2, O2, and CO2. These formulas must be correct and accurately represent the substances involved. Reactants in products are reacting substances that undergo chemical changes written on the left side of the equation. Products substance formed as a result of the chemical reaction written on the right side of the equation. The reactants in products are separated by arrow, and this in that indicates the direction of the reaction. Coefficients are numbers placed before the chemical formulas to balance the equation. They indicate the relative number of molecules or moles of the each reactants in product. For example, hydrogen, oxygen, water to represent the number of mole. Physical states of the substance, the physical state of each substance is often indicated in parentheses after its formula. S for solid, L for liquid, G for gas, and Q for aqueous dissolved in water. For example, NaCl solid is to liquid in carbon dioxide gas. Reaction conditions under which the reaction occurs, such as the temperature, pressure, catalyst, or other specific conditions may be indicated above or below the reaction arrow. Example, this has been like this delta heat. Significance of chemical equation. Chemical equations have also the two types of significance, qualitative and quantitative. Qualitative significance, identification of reactants and products. A chemical equation identifies the substance reactants that undergo a chemical change and the substance products that are formed as a result. For example, in equation S2 plus O2, S2, hydrogen, S2 and oxygen, O2 are reactants in the water S2 in the product. Types of the reactions, the equation indicates the type of the chemical reaction, example, combination, decomposition, displacement, or redox reaction, helping the chemist understand the underlying chemical process. State of the substance, the physical states of the reactants and the products, solid, liquid, gas, aqueous are the indicators providing the insight into the reaction environment and phase change, such as the precipitation or gas evolution. Direction of the reaction, the arrow in the chemical equation shows the direction of the reaction. A single arrow represents an irreversible reaction, while a double arrow signifies the reversible reaction, indicating the possibility of equilibrium. Reaction coefficient conditions like the temperature, pressure, catalyst, or light required for the reaction are mentioned above or below the arrow, providing the essential details for replicating or understanding the reaction process. Quantitative significance, the quantities aspects of the chemical equation provide numerical information about the amounts of reactants and products involved in the chemical reaction. Mole ratios, a balanced chemical equation gives the mole ratio of the reactants and products, which is crucial for stoichiometric calculation. For example, this reaction 2s2 goes to 2s2o. The mole ratio is the 2:1:2, indicating that the 2 moles of the hydrogen reacts with the 1 mole of the oxygen to produce the 2 moles of the water molecules. Mass conservation. The balance equation follows the law of the conservation of mass, ensuring that total mass of reactants equals that the total mass of the products. In this reaction, 4 grams of hydrogen combines with 32 grams of the oxygen to produce 36 grams of the water. Calculation of reactants and products, it allows the calculation of mass, volume, or number of molecules of reactants required to produce a certain amount of products or vice versa. And this reaction, water, hydrogen reacts with oxygen to produce water. 2 mole of hydrogen reacts with 1 mole of oxygen to produce 2 mole of water. That is the 2 into 6 0 to 3 10 to the power 23 reacts with 6.0 to 3 10 to the power 23 to produce 2 into 6.0 to 3 10 to the power 23 numbers of water molecules. Limitation of chemical equation, it does not state gas, solid, liquid of the substance. It does not explain the rate of reaction. It does not explain the concentration and condition of reaction, pressure, temperature, catalyst of reaction. Making the chemical equation more informative, chemical equation does not mention the state of the substance. To make the more informative, solid, liquid, gas should be indicated in the chemical equation. It does not give any information regarding the speed of reaction. To make the more informative, value of rate constant provided. It does not tell us about the concentration of the substance. To make the more informative terms like dilute, concentration should be used. See, this is the solid, this concentration, this aqueous, gas, liquid provided. It does not tell us about the condition of the reaction like temperature, pressure, catalyst. This is the catalyst, platinum is catalyst, and 450 to 500 degrees Celsius temperature. It does not give any idea about the color change during a chemical reaction. To make informative color change in mentioned separately. Yes, lead oxide, this is the brown, PbO brown, and PbO yellow, and oxygen is the colorless. It does not give any identification regarding the evolution or absorption of the heat, whether exothermic and endothermic. For example, carbon dioxide in water in presence of sunlight is it gives the glucose and oxygen. Is the endothermic reaction, that is energy is necessary for the reaction. So sunlight is necessary to react this reaction. If the glucose reacts with oxygen, produce this carbon dioxide in water and energy, adenosine triphosphate. This is the exothermic reaction, that is energy is evolved from the reaction. And balancing the chemical equation, a balanced chemical equation is the chemical equation in which the number of atoms of each element in the same or the both of the reactants and products side. In other words, balancing means the total number of atoms in reactants are equal to the total number of atoms in products, that is left hand side equal to right hand side. See, ammonia reacts with the oxygen to produce carbon dioxide in water. In this reaction, 1 carbon and 4 oxygen left inside in both, right inside, and 4 hydrogen left inside in the right inside. This is the balance equation, chemical equation. To balance the chemical equation, there are 2 types of method: hit and trial method. It is also known as the trial and error methods. In this method, coefficient whole number of place record the molecules or compounds that are adjusted. By trial, you need the number of atoms of each element on the reactant side equal to the number of atoms on the product side. Balance the following equation by heat and trial methods. For example, C3H8 plus O2 carbon dioxide plus water. List the number of atoms on both sides. 3 carbon, 8 hydrogen, oxygen 2, right inside 1, hydrogen 2, oxygen 2. 2 from the carbon dioxide and 1 from the water, you should add. Balance the carbon, there are the three carbon atoms on the left side and the only one on the right side. So you should add the three on the right hand side. Now the carbon atoms are balanced in the both sides. And balancing the hydrogen, there are the eight hydrogen atoms on left side and only two on right side. To balance the coefficient 4 in front of water, to balance force 8. So hydrogen is also balanced. The balance the oxygen, after balancing the carbon and hydrogen, count the oxygen atoms right inside products. There are the 10 oxygen atoms and 6 from carbon dioxide and 4 from the water. Left side reactants oxygen comes from the oxygen which has two oxygen atoms per molecule. To get 10 oxygen atoms, place the coefficient 5 in front of the water. So equation is the balance. Some techniques to balancing the chemical equation. Balance the chemical equation using the ones in two states. For example, potassium reacts with oxygen in the potassium oxide. Here see two oxygen on the left hand side and one oxygen on the right hand side. So to balance the, you should multiply the two before the right hand side and oxygen is balanced, and then after you balance the potassium. Balance the chemical equation by using the two centricity techniques. See, for example, iron reacts with oxygen to produce ferric oxide. Oxygen is the three on the left, right hand side, and the two on the left hand side. So exchange both sides 2 and 3. See, 3 is multiplied before the word 2 and 2 before the right inside to balance the oxygen, then after balance the iron. Balancing the chemical equation using the CSO techniques, it means that you balance the carbon first, then hydrogen, and at last oxygen. Uh, See, this is the CSO technique. So you balance the three carbon on the left hand side and the one carbon on the right hand side. So you balance the carbon first, then three, and before the carbon dioxide, you balance the carbon. Then after you balance the hydrogen, four, and before the water molecules in the hydrogen. At last, you balance the oxygen, multiplying the five before the oxygen. This is the CSO technique. Even number techniques, if you have an even number of certain elements on one side equation and the odd number on the same side of the element, together side of the equation, multiply by the two, which gives the given even number of both sides and make the equation easier to balance. For example, methanol reacts with the oxygen, produce the water and the carbon dioxide. Using the CSO, carbon is balanced, but hydrogen on the right side is okay, right side is the 2 and the 4 on the left side. So multiply it by 2 in front of water and to balance the hydrogen. See, 2 is multiplied before the water, and so hydrogen is also balanced. In this case, the 3 oxygen on left side and the 4 on the right side, so multiply by 2 on the both sides. So except oxygen atoms are balanced, so some coefficient of oxygen, that is the 3O2, and balancing the equation. Polyatomic techniques in polyatomic ions, the poly like sulfate, nitrate, left hand side and right side. You should treat these are the single unit, not sulfur and oxygen in not count. See, uh, in case of calcium and reacts with nitric acid to produce the hydrogen and calcium nitrate, you treat the nitrate as the single unit to balance. Uh, First of all, balance the hydros metal atoms. Calcium is the already balanced. So you see the hydrogen atoms right inside is the 2 and the left inside is 1. So multiply by 2 before the nitric acid. And the nitrate is the, you treat as the single unit. See, and the left hand side, 2 nitric acid means 2 nitrate, and to balance the nitrate in the right hand side, multiply by 2 calcium nitrate. General rules for balancing by the heat and trial methods: balance the metal first and balance the non-metal after balancing the metal, leaving the CSO. Partial equation method, it is the superior to heat and trial methods, which is applied in the complex reaction where some elements appears in more than one product. A given chemical reaction is broken into number of probable steps. Uh, these systems are also known as partial equations. Each partial equation are balanced by heat and trial method. Each of the partial equation is multiplied by the suitable numbers. The balanced partial equation is added to get the final equation. Idea for partial equation: potassium permanganate is breakdown into potassium oxide, magnesium oxide, and nascent oxygen. Similarly, potassium dichromate, potassium oxide, chromic oxide, and nascent oxygen, manganese oxide, and nascent oxygen. A nitric acid, different condition, concentrate, moderate, and dilute. So it gives all case water in the nascent oxygen, but in case of concentrate nitrogen dioxide, moderate nitric oxide, and dilute nitrous oxide. You remember this. In case of sulfuric acid, breakdown water, sulfur dioxide in nascent oxygen. The hydrogen peroxide produces the water in nascent oxygen. Ozone produces the oxygen in nascent oxygen. Some examples balancing by the partial equation method. For example, copper reacts with nitric acid, copper nitrate plus nitrogen dioxide plus water. First of all, you break down the nitric acid. It is the conc nitric acid. So nitrogen dioxide, water, nascent oxygen, and copper reacts with the nascent oxygen to produce copper oxide. And copper oxide again reacts with the nitric acid, copper nitrate, and water. These partial equations, this national oxygen are left hand side and right hand side, so cancel. Similarly, the copper oxide in copper oxide, left hand side and right side cancel. And at last, you add this copper and 2 nitric acid to 4 nitric acid, and this copper nitrate plus uh, nitrogen dioxide plus water. Another example, sulfur reacts with nitric acid, sulfuric acid and nitrogen dioxide plus water, and nitric acid breakdown in nitric dioxide, water, and nascent oxygen. Sulfur reacts with oxygen in sulfur trioxide. Sulfur trioxide reacts with water and sulfuric acid. So in this reaction, nascent oxygen is cancel and sulfur trioxide is also cancel. And at last, you sulfur and nitric acid, water, sulfuric acid, nitrogen dioxide in water. Another example, potassium permanganate. Potassium permanganate reacts with the hydrochloric acid, produces potassium chloride, magnesium chloride, water, and chlorine gas. This reaction takes place in 4 steps. First of all, potassium permanganate breakdown, potassium oxide, manganese oxide, and nascent oxygen. And potassium oxide reacts with hydrochloric acid, produces potassium chloride plus water. And also, manganese oxide reacts with hydrochloric acid, manganese chloride plus water. And the nascent oxygen also reacts with the hydrochloric acid, water, produce water in the chlorine. At last, you add okay, see, this in this example, potassium permanganate reacts with the hydrochloric acid and produce potassium chloride, manganese chloride, and water and chlorine. In first step, potassium permanganate break down into potassium oxide, manganese oxide, and nascent oxygen. Potassium oxide reacts with the hydrochloric acid to produce potassium chloride and water. Also, manganese oxide reacts with hydrochloric acid, manganese chloride plus water. And nascent oxide reacts with the hydrochloric acid, water plus chlorine. In this reaction, this potassium oxide is the left inside, right inside, so cancel. This magnesium oxide is multiplied by 2, and that is 2 manganese oxide also cancel. This is the nitrogen oxygen. This 5 nitrogen oxygen also cancel. You add the 2 potassium permanganate, 5 into 10 hydrochloric acid to 12, and 2 into 2 for 14, and 16 as hydrochloric acid. This 2 potassium chloride, this manganese chloride multiplied by 2, and 5 water and 7, 8, 8 water molecules, and this is the 5 chlorine. This is the balance equation. I'm discussing about basic concept of chemistry, some terms. Thanks for watching. Thank you for the patience. That is now. Bye bye. See you again.